Okay, good morning class. We are going to start with the equation of straight line now that you have got a basic understanding of the coordinate geometry in the previous classes also and in the previous chapter also. So one of the important chapters now that we have in 10th standard is the equation of straight line. Okay, straight line, everybody knows what that is, and we are going to study the equation of that straight line. So in the linear inequation chapter you must have seen, as well as in the previous year you must have seen something like let's say for example 3x plus 2y is equal to 5. Okay, this is just an example. You have already studied this in simultaneous linear equations. Okay, all straight lines are represented by linear equations. Okay, so the word linear comes from the power of the variables which are 1. Okay, so if you can see in this particular equation there are two variables x and y, and both the powers of both the variables are 1. Okay, so such an equation is called a linear equation, and that linear equation represents the straight line. Okay, so you may have two variables, you may have one variable only, it all depends upon the situation, but then it is linear equation which represents the straight line. Okay, so now let us start with some of the important terms that we have to understand before going into the details of the equation of straight line. The very first thing that you have to understand about a straight line is its slope. Okay, the word slope is also known as the gradient. Okay, so slope of a line, you can also say gradient of a line. Okay, so now what is this slope of a line? Now have a look here. In the Cartesian coordinate plane, I have shown you the positive x-axis, negative, same with y-axis also, and I have drawn two lines over here. You can see that this is a straight line. Okay, now what is the slope of this line going to be? How are we going to determine the slope of this line? Okay, because please remember, slope of a line is absolutely essential in determining the equation of a straight line. Okay, so we must first understand how to get the slope of a line, or what is the meaning of the slope of a line. So slope of a line is also known as the gradient of a line, and it is equal to the tangent of the angle which the line is making with the positive direction of the x-axis when taken in anti-clockwise direction. Okay, so you know that slope of a line or the gradient of a line is equal to tan theta, but you must know what theta is. Okay, so in this diagram, if you see, if I take this particular line, what is theta going to be, and how are you going to measure theta? So you see, from the positive direction of the x-axis, which is this side, when you go anti-clockwise, okay, you measure some angle. Okay, so that angle is theta. Okay, so suppose theta is 45. Let's say for example theta, in a particular case, that theta becomes 45 degrees. Okay, so what will your slope be? Your slope will be tan of 45, which is 1. Okay, so these standard angles, the trigonometric ratio, the tangential ratio, you already know. Okay, so this slope of the line is represented by a small letter m. Okay, so in most of the cases you will find in the book small m will be used to represent the slope of the line. Okay, which is also known as the gradient of the line, and it is equal to the tan of the angle theta. What is angle theta? It is the inclination of the line with the x-axis on the positive side or the right hand side. Okay, if you see, there is an angle being made this side also. Okay, there is an angle that is being made with this line and the x-axis on the left side also, but we are not going to take that. We are going to take the angle on the right hand side when taken in the anti-clockwise direction. Okay, so in any case it will be given to you in the question if you are asked the slope of the line. So angle theta will be given, you will directly put the value. So suppose let's say for another example, if theta is 30 degree. Okay, so what will be the slope of the line? The slope of the line will be tan 30, and tan 30, as we know, it is 1 by root 3. Okay, so that is the slope of the line. Now there are two aspects if you have a look at this diagram, the second straight line that I have drawn, now straight lines can be drawn in any fashion. They can go like this, like this, like this, like this, any which way, okay, as long as they are straight, okay. So if you have a look at this particular line and you look for theta, now this time theta, the positive side is this side, so you see anti-clockwise from the x-axis, anti-clockwise when we draw, this angle theta is, in this case, it is going to be an obtuse angle, okay. This angle theta was acute, that means less than 90, whereas this is obtuse. So there are two cases that will arise. Theta, when theta is acute, the slope of the line, the formula is the same. Even in obtuse, even when theta is obtuse, the slope is given by tan theta only, but then tan of an obtuse angle will become minus, okay. So in this particular case, the slope of this line will be minus, okay. Obviously the exact value will depend upon the exact angle theta, but as long as theta is obtuse, you will get the slope value in negative, okay. So please remember this, just to have a logical viewpoint in the mind. Whenever you see a line in general making an acute angle with the right side of the x-axis, then you can easily say that its slope is positive. Without assigning it a value, you can simply say that its slope is positive. Whereas if you see a line which is making an obtuse angle with the right side of the x-axis, you will say that its slope is negative, okay. Now finding the slope when theta is given, so that is simple. I have already told you, slope represented by small m, it is given by tan of theta. So this you can use when theta is known to you, okay, or given to you. Now you can always have another case scenario in which you are not being given theta, okay. So if I remove this angle theta from here and I tell you that this is a line which is passing through a point A and a point B, okay. Suppose I tell you that there is a line which is passing through two given points A and B. Find out the slope of that line. Now in this case, you don't know the theta, okay, you don't know the angle theta, so you cannot use this particular concept, okay. So what do you know in this particular case? You know 2 points through which the line is passing, okay. So supposing I take A value to be let's say 2 comma minus 2 and the value of B as 4 comma 2, okay, something like this. Suppose I have given you, or the question has given you 2 points and the coordinates of those 2 points, and they tell you that the straight line is passing through those 2 points. So in that case, how will you determine the slope of the line? Then the slope of the line, as you can see in the second case, finding the slope when 2 points are given. So this is first point, this is second point, x1 y1, x2 y2. The formula for slope will be y2 minus y1 upon x2 minus x1, or you can also write y1 minus y2 upon x1 minus x2, okay. So if you take this particular case, for example, if you take this particular case, the slope value will be, now you see, you have to indicate what is the point, first point, what is the second point. So suppose I write point A is 2 comma minus 2 and point B is 4 comma 2. These are the 2 points that are given, okay. So I can take this point to be x1 y1 and I can take this point to be x2 y2, okay, or you can reverse it also, no problem, okay. So what is the formula? The formula is y2 minus y1. So what is your y2? Y2 is 2, okay, minus, this minus is in the formula, okay. Now what is y1? Your y1 value is minus 2, okay, so you will put a minus 2 in bracket upon x2 minus x1. So x2 is 4 and x1 is 2, so you will have 4 minus 2, okay. So the slope value comes out to be, minus and minus will make it plus, so 2 plus 2 will become 4 and 4 minus 2 is 2, so 2 2s are 4. So you get a value of the slope of the line as 2, okay, 2 with a positive sign. So that obviously means, since we have a positive value of slope, that means this line must be making an acute angle with the positive side or the right hand side of the x-axis. Okay, so till now what we have discussed in the equation of a straight line, we have discussed the first terminology, which is the slope of the line, and please remember it is also known as the gradient of the line. There are two ways that we have discussed of finding the slope of a line. One, when theta is given, then you will use the formula m is equal to tan theta. M is the slope and theta is the angle. Similarly, when 2 points are given, you will use this formula to get the slope. Okay, so the next term that we are going to study is the word intercept. Okay, so intercepts cut by the straight line on the axes. Now axis is the plural word for axis. How many axes do you have? You have two axes on the Cartesian coordinate plane. You have the x-axis and you have the y-axis, as you can see. Okay, and this is our line which is passing. So these are some examples that I have taken just to help you understand the word intercept. Okay, now you see there are two kinds of intercepts that the line can make because there are two axes. Okay, so if we talk about the x-intercept, what does it mean? Now intercept word means the portion which is cut by the line, straight line on the axis. Which axis? Suppose I am talking about the x-axis. Okay, so this line is cutting a portion of this much. If you can see, this is the origin, okay, and this is the x-axis, this is the line that we are talking about. So if somebody asks you, what is the x-intercept being made by this line? So the x-intercept from the origin, if you see, this line is cutting the x-axis at this particular point. Okay, so from origin up to this point will be your x-intercept. Okay, it will be your x-intercept. Okay. Similarly, if a person wants to know what is the value of the y-intercept made by this line, so then you will look for the point where this line is cutting the y-axis. So y-axis is this, line is this. So where is it cutting? It is cutting at this particular point. So again, from the origin up to this point, you can say that this portion is known as the y-intercept. Okay, and this y-intercept is known as, or it is represented in the equations with a small letter c. Okay, please remember that this portion, which is the portion cut by the line on the y-axis, this is the y-axis, so this portion is known as the y-intercept and it is represented by a small letter c. Now obviously you have different cases possible. All the lines will not go like this. Okay, some lines can go like this, some lines can go like this, like this. Okay, so what will be the different case scenarios? I have taken a few examples over here. Now in this particular example, if somebody asks you what is the value of c, small c, so what is small c? Small c is the y-intercept. So y-intercept means the portion which the line is cutting on the or along the y-axis. So starting from the origin, if this is the origin, as you can see, this line is cutting the y-axis at this particular point. Okay, so from origin up to this point is your y-intercept, which is known as c. Okay, so this is the y-intercept here in this case. Similarly, what will be the y-intercept in this particular case? This line is, this time you see this line is not cutting the y-axis above the origin, it is cutting the y-axis below the origin. In fact, this is the point where it is cutting the y-axis. Okay, and this is the origin. Okay, so this time it is this value, this much, which is the y-intercept. So we are going to write c because c represents the y-intercept. You can obviously understand by looking at it that in this particular case the value of c will be positive because it is above the origin. In this particular case the c value will be negative. Similarly here the c value will be positive. Okay, so depending upon different case scenarios you will have different values of c. Please remember that y-intercept is a little more important, because your questions, the very first form of equation will deal with the y-intercept. Please remember that the letter small c represents the y-intercept in case of a straight line. Okay, so small c will represent that. Now, having learnt about the slope and the intercept, now let us understand the collinearity of points. Collinearity. Okay, so co is coming from the word same, and linearity is coming from the straight line. Okay, so collinearity of points basically signifies the points being in a straight line. Okay, now having the same slope. So how do we understand? Let us have a look at this particular diagram. There are 3 points A, B and C given to you. Okay, if we join these 3 points with a ruler, we find that all these 3 points are lying on the same straight line. Okay, as you can see, there is a single straight line that is passing through all these 3 points. So such points are known as collinear points. Okay, what points? They are known as collinear points. C-O-L-L-I-N-E-A-R. Collinear points. Had there been another point D, suppose for example over here somewhere. Okay, suppose there would have been a point D. So would that point D also be collinear with these 3 points? No. So out of these A, B, C, D, out of these 4 points, there are 3 points that are collinear. Collinear means in the same line. So these are 3 points, A, B and C. Okay. Okay, so what is so peculiar about these 3 points lying in the same straight line? What is the significance of that? Our eyes can see that these 3 points are lying on a straight line. But what is the significance of all these 3 points lying in a straight line in terms of this particular chapter? So you see, we are studying collinearity of the points. Now, when these 3 points are in the same line, that means there is only a single line that is being made. There is only a single straight line. So as long as the straight line is only one, it is only single, the theta angle that it is making, as you remember, the theta angle that we had discussed, from the right hand side or from the positive direction of the x-axis, if we go anti-clockwise, we will get an angle theta. Okay, so even if you forget about this point and you take these 2 points and you draw a straight line, that straight line is going to make this angle theta. Similarly, if you forget about the point C and you take only A and B, again it is going to be the same line that is going to be made. Again that angle will be angle theta. So what that means is, whenever there are 3 points or 4 points or maybe even more points lying on a straight line, that means the slope of that line is going to be same, even if you take BC point, AB point, AC point. Okay, you select any 2 points that you want to take. Even if you take AB, the straight line will be same. If you take BC, same straight line. If you take A and C, same straight line. So if the line is straight, if the straight line is same, then you will have the same angle theta being formed. That means the slope of that particular line will be same. Okay, so that means slope of the line AB will be the same as the slope of the line BC, or you can also say it will be equal to the slope of the line AC. Okay, so regardless of the 2 points that you take, you can choose any 2 points that you want and find out their slopes using the 2 points. I have already told you how to find out the slope of a line passing through 2 points. So regardless of the 2 points that you choose, if you find out the slope, their slopes are going to be same. If they are not coming out to be same, that means the points are not lying in a straight line. Okay, so for checking the collinearity of the points, you must find out the slope of the line using 2 points at a time, and they should come out to be same. We will take up an example to illustrate this. Okay, so here is a question that we will use to illustrate the point that we discussed just now. Check the collinearity of the points A, B and C. Okay, so there are 3 points. This time their coordinates are given and you have to check their collinearity. That means, are they lying in a straight line, on a straight line or not? Okay, or are they lying on in different positions so that it does not make a straight line. Okay, so these 3 are the points. We will once again, I will draw a rough diagram just to help you understand. Okay, this diagram is not necessary for the solution of this particular problem, but once again I will draw. Let's suppose this is A minus 1 comma 1, this is B which is 5 comma 7, and this is C 8 comma 10. Okay, if they are lying in a straight line, you see, if they are lying in a straight line, that means slope of BC and slope of AB, it is going to be same, because AB and BC are not different lines, it's the same line. Okay, so the condition, how will we check? We will take 2 points at a time and find out their slopes. If their slopes are coming equal, then they will be collinear. Okay, so condition for collinearity is, first of all, you find out the slope. M represents the slope of AB. Okay, so if we are taking A and B as the 2 points, then what will be the slope? Please remember the formula was y2 minus y1 upon x2 minus x1. Okay, so if you choose this to be x1 y1 and this point to be x2 y2, okay, so put the values y2 minus y1, so it will be 7 minus 1 upon x2 minus x1. x2 is 5 minus x1 is minus 1, so minus of minus 1 will make it plus 1. So you get 7 minus 1 is 6, 5 plus 1 is 6, so you get a slope as 1. So the slope of AB, okay, slope of AB, you can write here, the slope of AB has come out to be 1. Okay, similarly we will find out the slope of BC. Okay, so this time I am going to take these 2 points BC. So x1 y1 I will take as B and x2 y2 I will take as C. Again the formula is y2 minus y1 upon x2 minus x1. So y2 is 10 minus y1 is 7 upon x2 minus x1, so that is 8 minus 5. Okay, so 10 minus 7 comes out to be 3, 8 minus 5 also comes out to be 3, and you get the slope of BC also as 1. Okay, so you can see now slope of BC also is 1. Since their slopes are same, you see, since their slopes are same, that means their thetas will be same. Theta means their inclination will be same, and as you can see, inclination can be same only when all these 3 points are lying on a same straight line. Okay, suppose they were not lying on a straight line, suppose only A and B were in a line and C was somewhere here. Okay, so in that case AB would make this line and BC would make this line. These two would become different lines. Okay, so please remember the condition for collinearity of 3 points is what? Their slopes should be equal. Whose slopes should be equal? You select 2 points at a time, AB first and then you select BC, or you can select AB and you can select AC also. Calculate any 2 slopes, they should come out to be equal. If they are equal, that means they are collinear. Okay, here's another question based on what we have studied till now. If the slope of the line joining P and Q, so these are 2 points that are given. Okay, there is a line running through them. Okay, line joining P and Q. Okay, so you can simply just to understand more clearly, you draw a line, okay, and suppose that that line is passing through 2 points P and Q. These 2 points have been given, okay, and the slope of this particular line is minus 3 by 4. So if you read the question properly, if the slope of the line joining P and Q is minus 3 by 4, so that means the slope of PQ, okay, PQ you will write in small font right at the bottom, equal to minus 3 by 4. This is the information that is given, okay. Now the slope of this PQ line, which formula will we use? Okay, because you see P and Q are 2 points that are given, okay. So when 2 points are given, then you use the formula y2 minus y1 upon x2 minus x1, okay. And what is our motive? Our motive is to find this unknown k. Find k, okay, find k. Had these 2 points been given, then the slope would not have been given. But here in this case, the slope is given, 1 point is given, the other point has an unknown, okay. So slope of this particular line is minus 3 by 4, it is already given. Now we can always treat this point to be x1, y1 and this point to be x2, y2. So what will be the formula? The slope formula you can write on the right hand side, y2 minus y1 upon x2 minus x1. That's the general formula that we will use. So over here you see slope value is minus 3 by 4 equal to, now we put the values, y2 minus y1. What is your y2? y2 is minus 6 minus y1. y1 is 3, so minus 3 upon x2 minus x1. So x2 is 8 minus x1 is k, okay. So what will we do in the next step? Minus 3 by 4 equal to minus 6 and minus 3 will make it minus 9 upon 8 minus k, okay. This minus and this minus can get cancelled straightforward, and this 3 and 9 will go, you will get a 3 here. Cross multiply, you will have 8 minus k coming to this side equal to this 4 will come here and multiply with 3. So 4 3s are 12, okay. Minus k can be taken to the right side, it will become plus k. This 12 comes to this side, you will have 8 minus 12. So the value of k comes out to be minus 4, okay. So if the slope of the line joining the 2 points is given, you have to find an unknown. This is the formula to use, okay. Now coming to the last part of this lecture, we will start with the first form of the straight line. There are different forms in different situations, we will use different forms, okay. The very first and the basic one is slope intercept form of a straight line, okay. We have understood the word slope, we have understood the term intercept. Now we are going to study or start with the first form of straight line, and that will involve the slope also and it will involve the intercept also. So as you can see on the right side, y is equal to mx plus c is this slope intercept form. Why is this called slope intercept form? Because as you can see, m is the slope and small c is representing the y-intercept, okay. So if you know the slope of the line and if you know the y-intercept that it is making, how will you come up with the equation of a straight line? Y is equal to mx plus c is what we will use, okay. So again an illustration using an example or a question. Find the equation of a straight line. Now so this is the first question on equation of a straight line, okay. Whose inclination is theta is 30. So immediately we will list the values that are given. Theta value has been given as 30 degree. So the moment you have theta, you can immediately get the slope. The slope will be tan theta, so it will be tan of 30 degree, which will be 1 upon root 3, okay. So we know the slope, okay. Y-intercept is minus 2, so y-intercept means the value of c value is minus 2. So we know the slope, we know the y-intercept. Find the equation of the straight line. So what will we use? We will use y is equal to mx plus c. So y is equal to, what is the value of m? M value is 1 by root 3 x plus c. C value is minus 2, so you can simply write minus 2. Okay, so this is the equation of the straight line. If you want, you can take the LCM and bring root 3 this side also. Y is equal to mx plus c. So this is the equation of that straight line. If you want to cross multiply after taking LCM, you will have to write it like this: x minus 2 root 3 upon root 3. So I have taken the LCM as root 3. This root 3 comes this side, so you will have root 3y is equal to x minus 2 root 3. Okay, so this is also correct, this is also correct. Okay, so and once again, if you see this, since this is a straight line, all the powers of the variables will be 1. Okay, nothing else apart from 1. Clear? Now here's the last question. A simple question once again, just to make the basics very clear. Find the slope and the y-intercept of the straight line represented by this. Okay, so if you notice, this question and the one that we did just before this, they are exactly reverse, or the reverse of each other. In what sense? In the previous question, you were given the slope and the y-intercept, you were asked the straight line. In this question, you are given the straight line and you have been asked the slope and the y-intercept. Okay, so if the equation of a straight line is given, you only have to bring it into the form y is equal to mx plus c, because this is the form which is known as the slope-intercept form. Okay, since they want the slope and the y-intercept, therefore we will have to use this standard equation. Okay, so y is equal to mx plus c. Now this is the actual equation of straight line that you have been given. So you will have to separate y on one side. So you can take this y to the other side. So what you will do is just write down 2x minus y is equal to minus 1. Take this minus y to the right side, it will become plus y. Bring this minus 1 to the left side, so it will become 2x plus 1. Now this, if you observe carefully, this equation can be written as y is equal to 2x plus 1. I have just done the reciprocal. You have not reciprocal in the real sense. I have brought y onto the left side and the entire thing to the right side. Basically you have y on one side and the entire other thing on the other side. So what is the reason why I am doing this? Because you see, after doing this, once we have done this, you can easily see that if you write y is equal to mx plus c, this format is the same as this format. Okay, so I have done no change. The only thing that I have done is I have adjusted y and x and the constant term to bring the original equation into the y is equal to mx plus c form. Now when you compare, the value of m will be 2, the value of c will be 1. Okay, so you can write comparing, you have the slope value as 2 and the y-intercept as 1. Okay, these were the things that had been asked in the question. Okay, so I'll stop over here. I hope that you have understood the very basics. We are now going to go into the more relevant details of this chapter as far as the equation of line is concerned, the things that are asked. But these were the very basic things and very important things for you to remember and understand. Okay, so in the next lecture we will proceed ahead. Thank you.